In this video, I'm going to brief about terahertz waves. To me, this terahertz wave term itself is a new term which I have recently heard it in a talk. So I thought I would share with you some of the details which I have heard from the talk. Generally, we make use of electromagnetic radiations for our physics applications, starting from microwave to gamma rays. We have tapped all the electromagnetic radiations for developing a new technology. In the same way, this terahertz waves, which is also a part of electromagnetic radiations, has been used in recent times for different applications. This terahertz wave, which exists in nature, is a part of an electromagnetic radiation which is sitting in between microwave radiations and infrared radiations. Because of this reason, these terahertz waves are also called as far infrared radiations. So, this terahertz waves is nothing but it is a part of an electromagnetic wave which has its spectrum lying between the microwave and infrared radiations. These terahertz waves are highly interesting because they have the advantage of low energy, and this technique is these radiations are non-invasive, non-radiative, and we can do a high resolution imaging, and they have a good penetration in certain materials. These advantages make this terahertz waves interesting to study in these recent days. The terahertz waves have following properties. They are high frequency waves, as the name suggests. Their frequency ranges in 10 power 12. 10 power 12 is 1 tera. So the frequency of the terahertz waves is 10 power 12 hertz. Typically we call the radiation which is lying between 0.1 terahertz to 10 terahertz as terahertz waves. And the wavelength is very small, around 3 mm to 30 micrometer in vacuum. So they have the range is very small, and they have a very low energy of about 4.14 million electron volt, which instead of using a high penetration X-rays or the high energy X-rays, this terahertz waves may form an alternative to X-rays. And these terahertz waves can penetrate through plastics, papers, cardboard, ceramics, and they are also reflected by metals. So we can make use of this property of terahertz waves to probe more into materials which X-rays cannot penetrate through. And these are highly non-radiative and non-ionizing, unlike X-rays. So this property of T waves makes them an alternate to X-rays, where X-rays has the property of ionizing the body or any object, and they are radiative also. So we can make use of this terahertz wave where we cannot apply X-rays, and these waves are strongly absorbed by water. Generally, we can produce terahertz waves by two ways, either by natural ways and another by artificial waves. In nature, our sun is a very good source of terahertz waves, but when they cross the atmosphere, since the terahertz waves are absorbed by water, we cannot trap much of the natural source of terahertz waves. So we have to go for a well-defined artificial process of producing terahertz waves. So what makes the scientists to go for terahertz wave? Because they find a wide applications in security imaging. See, in most security checks, we make use of X-rays for check, but X-rays cannot penetrate through certain concealed boxes, and they are highly non-radiative. So, for security imaging, for the high precision security imaging, we can make use of this T waves where we cannot employ X-rays. Since they are shorter waves, we can help. They can help us in rapid communication. Now we are in the era of developing, moving into 4G to 5G. So this terahertz waves may take us to a rapid communication of moving into 6G. Since their wavelength is very less, we can use it for short and wireless communications, and they find wide applications in electronic industries. Yes, as I was mentioning, uh, these tera waves can be used to detect concealed weapons and objects. This is one of the most important applications of terahertz waves. And we cannot use this terahertz waves for a longer distance, um, but for a shorter range we can use it for a in satellite communication too, and they are highly helpful in communication in a compact range in an ultra fast way, and they are helpful in doing chip to chip communication too. And in medical field they are highly helpful in doing spectroscopic imaging, to finding the changes in DNA and protein. And in dentistry we can create a 3D image of a broken tooth or a decayed tooth and damaged tooth and fixing in it. So these wide application finds the terahertz waves at the most favorite in recent times. Though this wave has a longer, wide applications, there are a lot of limitations that is posed to this technology. See, firstly, the most of the terahertz wave which we receive in nature are greatly absorbed by water. Since our atmosphere has minor traces of water molecules, these water molecule absorb the terahertz wave that is coming out of the sun. So we need to find for an innovative production technology. This is the greatest limitation, and this technology is very expensive. Though we produce it artificially, it is not cost effective. So we have to the main challenge in front of us is to we have to go for good non-linear crystals which can produce this terahertz waves.